Okay, picking up where we left off, or on page 224, looking at this diagram of how the relational, the database model, how the database, the relational database model, the database approach, a lot of different terms for this. And the major key factor is there's one guy in the middle that basically handles all the access. So the payroll people talk through this and it goes to the single database. If, for some reason, the invoicing people and the inventory control people wanted to get together and get in here and do some extra stuff, they can. You can combine all this stuff together. Now, having said all this, doesn't this look awful lot like that ERP diagram from a couple of chapters ago? Remember we talked about how the most defining factor of a enterprise resource planning tool was it had a central database? Remember that? Nod your head. Yes, of course you remember that. Well, that's what we're talking about. The database approach means everything is stored into a central database rather than having individual files. Okay. The next thing to talk about is kind of sort of how you go about building a database. And this is a little complex. And the reason why this is a little weird, I'm going to say something that's going to sound stupid, but it kind of makes sense. You should probably go through and do what's called a database model before you start to build the database. And the reason is, if you don't know how things are related in real life, you don't know the relationship between this organization and this organization or this part of the company. If you don't know those relationships, there's no way you can build a database that's going to mimic that. So you need to be able to model the data. And when you're doing data modeling, you're not necessarily modeling, you end up with model of the data, but you actually start off with a model of real life. You're trying to come up with the real life kind of thing. So he says, carefully consider the following questions. What data will be collected and at what cost? It could be that my appetite is this big for data, but my budget is this big. That happens, right? The access. Who should be provided, read and write access? This is a very important thing because you don't want to have everyone having access to the financial data, for example. Logical structure. In other words, when this thing is presented to the model is presented, how is it going to look to the user? Is it going to be organized so that they can put the little puzzle pieces together? And is it going to make sense? Now, behind the scenes is a thing called a physical model. The physical organization of the data. And that, the only person who really needs to know that is the database administrator. Because the user might see, a table. And then behind the scenes, this table is actually broken into two parts, and one part stored over here and one other part stored over there. But users don't need to know that. So these are the model characteristics that you need to take into consideration. So the whole concept of enterprise data modeling is this idea of typically what's called an entity relationship diagram. Now, entity, remember that term? A person, place, or thing, but it's a tiny thing. It's not everything in the world. It's only those things that are somehow related, like the example I give of address. The city and the state and the zip are all related to the person's address. If you don't put a shoe size in that, because shoe size has got nothing to do with the address. You don't put in mother's maiden name because that's got nothing to do with the address. So only those things, the entity contains only those attributes which are relevant for that entity. So don't mix and match. It's just one thing. So if you build these entities, here's an example of one that's kind of, I hate it when they do that. Okay, I'm not going to drag and drop these guys, but the way it works is, you could have a person, ordering parts. I guess we basically just need to do this, don't we? Doggone it. I hate that. Okay. Let's do customer. Whoops. I don't have it right, do I? Okay, salesman. Serves customers. And they place order, which includes line items, which specifies a particular product, and generates an invoice. All right, now that I got the thing built, let's go through it a little more. This is what's called a crow's foot notation. What it basically means is, this is the thing you're trying to model, right? You're trying to model how things work in real life so you can build the database. And so in real life, a single salesperson could have multiple customers. That's a relationship you kind of need to know. A single customer could place multiple orders. Yep, that'd be good to know. A single order could have multiple line items. And it could be that a single product has multiple lines. In other words, I'm buying a laptop computer, but it has this screen, this RAM, this hard drive, line items that specify a single product, okay? And then the order generates an invoice. So every order has one invoice. So that's this crow's foot notation. So bottom line is, you're trying to model how things work in the real life. And once you understand how this works in the real life, then when it comes time to building a database, oh, you've got the game beat. Okay? Cool. This is considered a one-to-many organization, a little crow's foot. So one salesman has multiple customers. But here, a one-to-one. A single order produces only a single invoice. Okay. And here's a one order could have multiple line items, and here's one product can have multiple. So there are scenarios where there's a many-to-many, but those are kind of rare. Okay. So that's basically how that thing works. So let's go back to this whole concept of this relational model. There's some terms here we're going to have to go through, and I guess we'll just go through them now. Okay, here are some database terms that might show up on a quiz. The first one is called domain. And the term domain in the context of a database means all of the range of valid values. So for example, if in my my employee database I have a table talking about hire date. Okay, well, the range of valid values are probably going to be between 1950 something and the current date, right? Because most likely you're not going to have anyone there who's like 100 years old, right? Most likely. And so the range of valid values for that field is called the domain. All right, the next one is talking about making a selection. A selection is a technique for reducing the number of rows that appear in a result. So for example, if a database table has 10,000 rows in it, and I didn't have any selection whatsoever, when I ask it a question, I would get 10,000 answers, 10,000 rows every single time. So there's a technique where you can do to go in and give it a condition so that you, for example, you could say, give me only the customers from the state of Texas. And that'll reduce, number of rows down significantly. So a selection is all about reducing the number of rows. Now, there's another term called a projection. And a projection is reducing the number of columns that show up. So, for example, if I'm doing this query, I really don't care about their street address or their zip code. All I want to know is the city. So I'm picking the columns that are going to show up in my result set. And yes, you can combine both a selection and a projection simultaneously. Now, one more time. A selection is for reducing the number of rows, and a projection is for reducing the number of columns. Okay, next one is called joining, and which is what this thing is about to show. All right, here goes. So here's an entity called a project, and these are just arbitrary numbers, so it's a payroll. That's the widgets, and this is sales manual, whatever. And then you have a department table. So this is the table showing all the departments. And then you have a manager table. And so I'm trying to determine, how do you stitch this together? If I'm trying to find out who is the manager for the widgets, all right, that's what I want to know. Who is the manager for widgets? Well, I don't find the answer here, because that's just the manager table. I don't find it here. And I don't find it here, so I have to stitch these tables together. I have to link this table to this table. I have to go through here and find all these departments. So here's department number 632, and I stitch this together and find out that widgets are being managed by Bill Buckley. And that's what we would do with linking. Linking means I take these individual small entity pieces and combine them together, link them together so I can join or make a relationship between the managers and the actual, whatever I'm after, like who's the manager over widgets. Okay, that's essentially how that part works. All right, so here's those terms. So here's a simplified diagram one more time, just to kind of drive home the point. A single manager, and I love the way they actually put verbs out here to kind of help visualize this. This is an entity relationship diagram, an ERD. Manager supervises many departments, and many departments perform many projects. And so if you know that's the relationship, then when you build this thing, you know how to stitch them together. Okay, that's kind of how that works. Whew. All right. So you might ask yourself, well, why do I bother to break these things up into tiny pieces? Why don't I just go ahead and have one giant table that has everything that I want? Well, the problem is you're going to have duplication. If you, instead of having these 3 separate little pieces, I just had one giant table. That means the manager would, let's say that there's 3 departments and 5 projects, okay? 3 and 5 each, okay? 3 departments, each one has 5. That tells me there'd be 15, right? 15 lines for each manager. So a manager would have 15, so his name would appear 15 times in the database. So whenever a manager's name appears 15 times, that's bad. And the reason is, the guy, let's say you swapped out managers, or you find a misspelling, or he changes his name, and you go in there to modify it, you would have to do a search and replace. You'd have to go through every single row hunting for that guy's name to fix it. This technique, he only appears one time in the table. So whenever I change his name here, then presto changeo, it magically updates everywhere in all of the views. That's the key to it all. It makes it easy to maintain. Duplicated records is always bad. Okay. Whew. So here's a scenario where they're trying to link those things together like I just described. So, they cut and paste. I grab a piece of this piece and a piece of that piece and a piece of that piece, and I end up with exactly what I want. Project tables and department tables and manager. You pick and choose. So I wanted to find out, in this particular case, a sales manager went to the department went to the manager went to this, and so, boom, 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 boom. Tells me everything I need to know. So you do have to stitch them together in order for it to make sense. Okay. All right. Next thing we're going to talk about is I've got data and perhaps it's not in good shape. And I mentioned before that, good data allows you to make good business decisions. And so bad data is probably the opposite. So let me tell you a story. So 10 million years ago, I had a job, and I was at Fort Hood, and we were working with this database that had soldiers' addresses, okay? Their home addresses. And we were getting ready to move it to a real, honest-to-God, relational database. Woohoo! All right, so we're doing that transition we just talked about. The before relational database where everything was stuck in a file and didn't talk to anything. We were going to put it into an honest-to-God, real Oracle database. All right. So one of the things was we wanted to clean up some of the data. And I was stunned, for example, because each soldier would enter their data kind of sort of by themselves. I was stunned at the number of spellings for the word Copperas Cove. The city of Copperas Cove has one proper spelling, but there was like 30 and 40 different types of misspelling for that one word. So when I moved it to my new database, I wanted to have one spelling. Okay, we're going to continue this conversation in just a few.